Hi everyone. Today in this session, I will talk about Crossplane and specifically Crossplane with AWS. So before jumping into the session, I would like to mention, please engage yourself in this conversation. Feel free to drop your suggestions and have all your queries resolved and discuss whatever comes to your mind during this session. All right. And if you want to discuss it further or if your queries aren't resolved, you can reach out to me in Teams and we can connect on that. All right. Let's discuss the knowledge study case first. Please join the session 5 minutes prior to the session start time. We start on time and we conclude on time. Please make sure to submit a constructive feedback for all the sessions as it is very helpful for the presenter. Keep your mobile devices in silent mode and feel free to move out of the session in case you need to attend an urgent call. And please avoid unwanted chit chat during the session. The agenda that we would be discussing today is prerequisites. It would be an introduction to Kubernetes and a general idea of how things work around Kubernetes. We would come to what is Crossplane, how and why should we use Crossplane, and its comparison and alternatives present in the market, followed by a demo. So can someone please switch on their mic and describe what is Kubernetes? Probably somebody from DevOps.
I can do that.
Yes. Can I?
Go ahead.
Yeah, go ahead.
For sure. Go ahead.
Kubernetes is an open source orchestration tool, and we can use Kubernetes to deploy applications in multiple servers. This is the basic.
Okay.
Yes.
Correct. So yeah, Kubernetes is open source container orchestration engine for automating the deployment, as you said. Basically, what it does is it allows us to deploy, it allows us to scale and manage the containers, for example, Docker containers, very easily and very efficiently across multiple hosts or servers. So it will take care of your deployments, it will direct your deployments and make sure they run very smoothly. And we create the Kubernetes workloads and we manage them like the workloads including deployment services, ingress, etc. And we query these workloads using a utility called kubectl client. Are you guys aware of kubectl client? It's just a client that would basically be a binary that you can use to query your workloads. For example, if you want to check the status of the pods, you can just do kubectl get pods. So this is how you interact with the Kubernetes cluster. All right. Please feel free to switch on your mic and be responsive. Moving to a general idea, it's very easy. Users will write their application code and they will store it in any of the repositories available, such as GitHub or Bitbucket. We can use any of the CI tool, such as Travis CI, Jenkins, or Buildkite to integrate the code. It will also track the changes. It will run test cases as described by you. It will then build the artifact and probably push those artifacts to a centralized repository. And generally, we work on a microservice-based architecture, which includes microservices, and we deploy the containerized applications. So the deployment of these microservices is taken care by CD tools, such as Jenkins again and Argo CD, which are the leading CD tools in the market right now. So they will also maintain and track the releases of your application in multiple environments. We have a Kubernetes cluster. This Kubernetes cluster can be hosted anywhere. It could be either on-prem or on cloud. Also, on the other hand, we make use of various managed services offered by various cloud providers. Since this session is specific to AWS, we'll be talking about the managed services that are provided by AWS, such as EC2, S3, RDS, Route 53, and many others. So for this, we typically use any infrastructure as a code tool, such as Terraform, which is obviously an open source tool. And we can also use a cloud provider specific tool. In this case, we can use AWS CloudFormation to spin up the infrastructure that is required. So our infrastructure can include multiple services, EC2, S3, RDS, Route 53, etc. But if we take an example of a very basic web application that is written in any language you could assume, and we would deploy this application in the form of a microservice, and the object within the S3 bucket can serve as the index HTML pages, and it can reflect on the content of web pages. So EKS would host the backend of your application, and the logs or data which is generated by the application can then be stored on RDS. And a load balancer can be added to the front-end web app, and subsequent entries of load balancer can be done in Route 53. So basically, what I'm trying to say is any application deployment and infrastructure hosting is done hand in hand. And to query or visualize the application deployment in Kubernetes cluster, we typically use kubectl utility. In case of pods, we do kubectl get pods. In case of deployments, we do kubectl get deployments. Similarly, in the case of service ingress and extra other objects that we describe in Kubernetes, we would use the kubectl client. Right, and if we want to check the status of managed components or managed services provided by the cloud provider, which is AWS here, we can use the AWS CLI utility, or we can directly go to the console and check it. Right, so this was the general idea. Any questions here, or should I repeat something?
So what is Route 53? Can you explain again?
Route 53 is is an AWS service that will hold your DNS records. It's also a part of your infrastructure component that you would typically require when you host your application in the cloud.
So where the service will be transferring, it's about all that.
Can you come again?
Where the service will be going to transfer, it's all about that Route 53.
Yeah, it's a domain name server record. So basically, let's say I'm hosting a website. It is hosted at noldus.org, right? We would add this particular record and map it with the load balancer that is actually running to map or to balance the load within the pods that are hosting your applications within your cluster, Kubernetes cluster. That is one example of how a Route 53 would work.
Okay.
Just going to this overview again, you would write any application. You can store this application code in your GitHub repository. Similarly, this repository would also contain your infrastructure as a code files, which would be, let's say in case of Terraform, you'll have your Terraform manifest stored here. A CI tool will be in place. Let's say if you talk about Jenkins, it will be triggered. The pipeline will be triggered as you might have mentioned in your Jenkins pipeline. Let's say if it is taking the commits, a webhook will be automatically triggering the pipeline, which would then continuously integrate the code and will run all those test cases which are defined by you. Once these test cases have passed successfully, this will also generate an artifact. Let's say in this case, if we take an example of Docker, it will create a Docker image out of it, and it will push that Docker image to a repository, which would be either Docker Hub, your private repository, or Nexus, or any other centralized repository that you might want to use. This CD tool will be extracting those images, and it will be using either hemp releases or basic kubectl manifest apply commands to deploy all those applications in your Kubernetes cluster. So this is the EKS. EKS will be hosting the Kubernetes for you, and this application might also require managed services by AWS or any other cloud. But in this scenario, let's assume it's using S3, EC2, Route 53, or RDS. It might also use other AWS services such as Kinesis, CloudFront probably. So we will have infrastructure defined as code by the help of either Terraform or CloudFormation or any other tool that you might want to use. And these will work in coordination with your application deployment. Right, so this is the general idea. And we would also have multiple other components related to security, monitoring, and service discovery, etc. But this is just enough for us to get familiarized with the essence of Crossplane. Right, so yeah, I already discussed the query procedure. Coming to the topic, what is Crossplane? Crossplane is Kubernetes extension. And by this, I want to emphasize on the fact that this is a Kubernetes extension. It is not just some other infrastructure as a code tool in the market. It is a Kubernetes extension that is actually open source. It can also turn the cluster into a centralized control plane that is universal. And by this, I mean to say it will eliminate the infrastructure as a code tool usage, and it will serve as a central or universal control plane that could also create your infrastructure or manage your infrastructure within the Kubernetes cluster, since it is a Kubernetes extension. Right, and it is very easy to use, and it is based on Kubernetes APIs. So it's not it's an abstraction layer. Basically, you need not to bother about the code that lies within the Crossplane or how it manages to do so. You just have to define the custom CRDs for the objects that you want to create, and you can just create any AWS resource by defining the manifest, as you do for pods, services, and other Kubernetes objects. Right. So now that we have expanded the Kubernetes functionalities to include the coordination of managed services provided by several cloud providers, including the infrastructure components, we have Crossplane as a leading solution that is, again, a Kubernetes extension. So why should we use Crossplane? We have other infrastructures code tool in market. We had Terraform. We also had cloud provider specific tools. In case of AWS, we had CloudFormation. So why are we focusing on Crossplane right now? There are several reasons, obviously, but the most important one being the Kubernetes integration. We have been using Kubernetes extensively to host our applications, and Crossplane is specifically built to work with Kubernetes. Therefore, it makes it very easy for us to manage the applications deployment as well as the infrastructure components from a single place. Right. It also provides multi-cloud support. Well, so does Terraform. But in this session, since we are focusing on AWS cloud provider, but the Crossplane is not just restricted to AWS. It is designed to work with multiple cloud providers. Custom resource definitions. We can define CRDs. As I mentioned before, we can define CRDs to represent cloud resources as Kubernetes objects. So this makes it very easy for us to define cloud resources as code. We'll discuss more about custom resource definitions in the demo, but yeah, this is a general idea of it. Then again, a very important feature that makes Crossplane a little bit different from other infrastructure as a code tool in the market, which is policy as code. We can define policies using DSL. DSL is a domain-specific language called constraint template. Basically, constraint template will contain a set of constraints that can be applied to Kubernetes objects. For example, if we want all the S3 buckets to have versioning enabled, right, we will create a constraint template which will apply the constraint of versioning set to true. And when we spin up the S3 bucket using Crossplane, it will automatically check whether we have enabled the versioning or not. And if it's not enabled, it will not create the bucket for us. And lastly, the community support. Crossplane is a very new tool and it is still under development, but it has a good community support. It has various contributors who have been working actively towards the improvement of the tool. Any questions up till now? You might have got a gist of what is Crossplane at this point of time.
Can you explain policy as a code once again, please?
I'm sorry, there's disturbance in your background. Can you come again?
Can you please explain policy as a code again?
Okay. What I heard was, can you explain policy as a code again, right? Okay. Basically, policy as a code is when we define a policy, which in case of Crossplane is defined in constraint template. And the example that I gave was, let's say if we want a policy to be set, wherein we want all the S3 buckets that are created to have versioning set to true, right? Or let's say in case of instances, if we want the instance class to be T2 micro. If we want to restrict Crossplane to only allow the instances that have instance type set to T2.micro, we can define a constraint template for it. And only if this constraint is met, then only the Crossplane will allow the EC2 instance to be created. Otherwise, it won't. This is policy as a code. Did you get the point, or?
Yes, got it.
I'm sorry, I'm not able to hear you clearly. Can somebody tell me if they would have heard what he said?
Yes, sir. He understands it.
Okay, all right, perfect. So coming to how, why should we use it? We already discussed this. How does Crossplane work? So Crossplane will create Kubernetes custom resource definitions, as I told earlier. So it will represent the external resources. The external resources means the AWS managed services as custom resource definitions in the Kubernetes object format. So a user can create, update, or delete the resource via the kubectl client. And it can also act as a central controller that will manage external resources, and it will provide state enforcement. We can check the status of any AWS service that we spin up. So usually what we did earlier to check the status of pods or to get all the pods that we deployed, we typed kubectl get pods, right? Similarly, if you want to know the list of the buckets that got spinned up by Crossplane, we could do kubectl get buckets. It's that easy for us to manage. So yeah, and if something modifies or deletes a resource outside of the Kubernetes cluster, then Crossplane will reverse the change, or it will recreate the deleted resource. If you are familiar with the Terraform, Terraform also refreshes the state to know if the declarative syntax that you defined actually matches with the actual state of the resource. So Crossplane does this task automatically. It will continuously check for your environment every 30 seconds. It will poll for your environment, and then it will check whether the object is present as you have described in your manifest or not. If that object gets deleted by you or by any other person, the default nature of Crossplane would be to recreate that resource immediately. And obviously, we can change this behavior of Crossplane, but the default feature of it will be to recreate that resource which is deleted or modified. Right. So this is how Crossplane works. With AWS, it's the same. We have a Crossplane deployment, which is running on EKS cluster. We have other deployments, which is hosting our application as a containerized application. And we have Crossplane, which is also creating and managing the infrastructure within the AWS cloud. A user will be using kubectl utility to get the status of pods, replica sets, deployments, etc., as well as the same utility will be used to get the status of EC2 instances, S3, or any other service. Right? How does Crossplane work with AWS using CD tool? It's very easy, because recently Crossplane has extended its combination with leading CD tools in the market, such as Argo CD. So it's very easy for any user, even let's say the users from other teams, to just visualize the deployments and check the status of managed services from the same Argo CD console. And we can also restrict the users or the teams to have read, update, or delete access for specific resources in the required environment by setting up RBAC in Argo. And I'm talking about RBAC in Argo, not about RBAC in Crossplane. That is entirely a different concept. So yeah, these users can see or visualize whatever we have defined in their RBAC policies, only those amount of resources and in only that particular environment, so that they do not accidentally make changes that could disrupt the environment. So yeah, Crossplane has a good integration with Argo CD tool and other CD tools in the market as well. Alternatives and comparison, we have other infrastructure as a code tool in the market. So obviously we discussed a lot about Terraform. It is very powerful. Terraform is a very powerful tool, and it works on managing infrastructure as a code. It is not cloud specific, which means that it can work with multiple cloud providers. So does Crossplane. And both Crossplane and Terraform uses provider plugins, and they both follow the same declarative approach. So to be honest, it would be very wrong to say that Crossplane is better than Terraform. Both are great depending on how you want to use them, but Terraform is mostly focused on setting up the infrastructure wherein your application do not require Kubernetes to be involved. Let's say your application is entirely serverless, you're hosting something entirely in AWS managed or any other cloud specific managed services, and you're not using any Kubernetes cluster, then obviously you wouldn't spin up the cluster just to have Crossplane enabled. You would only add any infrastructure as a code to, let's say, Terraform in that use case. So this is just when you have an application that you want to host in your cluster, Kubernetes cluster, and you want to visualize the applications as well as the resources consumed by the applications in the same picture. So this is where Crossplane is better than Terraform. But other than that, I would say Terraform is still the most powerful tool, AIC tool in the market. All right. Before we jump into the demo, does anybody have any questions up to here? Okay, I would take that as a no. Okay. All right. So this is a playground for Crossplane with AWS. I have it in my Code Cloud account. This has already Crossplane installed, and the Crossplane is up and running as a deployment. But if you want to set up Crossplane from scratch, you just need to install the Helm chart for it. The current latest version for Crossplane is version 1.11.3. I suppose so. If you want to see, we have a Crossplane deployed in Crossplane-system namespace. So this is a Helm deployment by the name of Crossplane. And if you want to check the deployments that it created, we would have it in the same namespace by the name of Crossplane and Crossplane RBAC Manager. So right now you would be able to see 3 deployments, but only 2 deployments are the part of Crossplane. The third deployment is, again, since it's a predefined environment, so they already created the Crossplane provider AWS for us. I'll describe what it is later, but let's first jump into Crossplane deployment. If I describe this deployment, it has 2 containers. So the first container obviously is the init container. The init container is by the name of Crossplane init. So this is actually used to install all the Crossplane CRDs into the Kubernetes cluster, which a Crossplane definitely wants us to use. So Crossplane has another component called, container called Crossplane, which is again the only controller that will enable us to set up our infrastructure in any provider. Then we had another deployment called RBAC, Crossplane RBAC Manager. This way, basically, it will allow or it will create or manage the Kubernetes cluster roles for the installed Crossplane providers and their custom resource definitions. So the RBAC is very important part of Crossplane. It will automatically get installed so that whenever you create a custom CRD, it will associate the necessary cluster role for it. So basically, whenever we have this environment ready, we'll automatically have provider AWS configured. But if you are doing it from scratch and if you are hosting it in your EKS cluster, which by default does not have Crossplane enabled on it, then you'll have to set up the AWS provider. The work of a provider is to tell Crossplane that I am going to use AWS provider, and this is the package that I'm going to use. So what it will do, once you configure it, it will download all the necessary CRDs which are related to your cloud provider. So if I do kubectl get CRDs and if I grep for AWS, it will give me the list of CRDs that your provider will instruct Crossplane to install in your Kubernetes. So this is, since we are working on AWS cloud provider, it has added all the CRDs for, let's say, VPC, VPC endpoint, pairing connections, target groups, servers, load balancers, clusters, buckets, etc. So all the CRDs have been pre-installed, right? And since Crossplane is a Kubernetes extension, it makes use of Kubernetes API endpoints. So if I do kubectl API resources, and if I grep for Crossplane, it will give me the list of API resources that Crossplane or we might be able to use in our manifest when we define any object. So in our example, we'd be creating an S3 bucket. So let's see the API resource for bucket. It has two API resources. One is bucket policies, the other is buckets. The kind obviously would be bucket. So this is the API that we will be using when we define the manifest for an S3 bucket. Right. So this is the main task of any provider that we apply to our Kubernetes. So once this is done, we have another very important file called providerconfig.yaml. This is how you will be able to authenticate or authorize yourself to the provider that you want to spin up your cluster in. For example, in our case, we want to set up the infrastructure in AWS. We will create a provider config. The provider config will be pointing right now, as you can see, it is pointing to a secret. This secret is specified in Crossplane system namespace, and the secret is created by the name of AWS creds. So let's have a look at this secret. Yeah, so this is the secret, AWS creds, and if I get the secret, YAML format, it will give me a data which is only containing the information called creds. This creds is actually holding the base64 encoded data, which has AWS access key and secret key defined. So the purpose of provider config is to direct the Crossplane to use this particular secret, and in this particular secret, go for the key called creds. This creds will contain AWS access key and secret key, right? So this is how it would work. Any questions or any doubts up till here? Okay, not a problem. So having said that, we have already defined provider config. Let's have a look at the manifest for bucket. This example includes a basic S3 bucket creation. So when we write manifest for pod or any other deployments or any other workloads in Kubernetes, we generally use this format of YAML, right? We define API version for Kubernetes to use. We define a kind, which in case of pods, we define pods. In case of deployments, we define deployments, and so on. So right now, if we want to spin up AWS managed service, we define the kind to be bucket. And you can obviously visualize the same by defining kubectl API resources, and you can grep for bucket. So it will give you exactly what to define here. As you can see, this is v1 beta 1, and the object is bucket. And similar to what you define in your workloads, it has a metadata constraint which will have name and namespace defined under specifications. If you are familiar with Terraform, this is what you generally do inside a resource block. So you defined all the configurations within that resource block, and similarly, the configurations for bucket, you'd be defining it in the specs section of it. Lastly, the very important point is the provider config ref. This will instruct the Crossplane to include this provider config, which is default, which we created earlier here. So this provider config, again, is the one that will point out to the AWS credentials that it needs to take into consideration before applying this. So yeah, this is the basic YAML of S3 bucket. If I apply this S3 bucket YAML, and this is, as you can see, it is run by kubectl utility, no other client required. So it says unchanged because I already applied it, and you can get the status of bucket by just typing kubectl get bucket, and it will show you that this bucket is created. If you want to describe this bucket, we'll do it in the similar fashion. I misspelled kubectl. Okay, yeah, so it says it also provides you with the ARN of the bucket. It will tell you the status of the bucket. It will also tell you whether the ACL was set to private and the location constraint that you already defined in your template, and the other things that you generally would see in the configuration section of an S3 bucket. So if you want to see the same thing on the console, this is the S3 management console, and this is the bucket that got created with it. And the very important feature of Crossplane that I described earlier, if we delete anything that is created by Crossplane from outside the Kubernetes cluster, let's say if I went to the console and I try to delete this S3 bucket, I'd be able to delete it. Let me actually delete this bucket. So if I delete this bucket, obviously Crossplane is polling continuously for these changes in the environment, and it will get notified that the bucket is deleted. The default behavior, as I already mentioned, of Crossplane is to recreate the resource that got deleted. So see, it recreated this resource. The time is 1650, which is the current time. So yeah, Crossplane, default nature of Crossplane would be to recreate the resource which got deleted outside the Kubernetes cluster. And if we actually want to delete this bucket, it is, again, similar to what you do with Kubernetes workloads, kubectl delete bucket, and then the name of the bucket. Yeah, so it says bucket has been deleted. No resource found. You don't have any buckets. So yeah, this is a brief about how Crossplane work, how Crossplane spins up the infrastructure. The other examples could also include EC2 instances. We have a manifest defined for VPC. We have a manifest defined for internet gateways, route tables, instances, and everything in the Crossplane. So we can use this simple manifest to spin up everything via the kubectl utility. And similarly, if we talk about the integration with Argo CD, we just have to create apps. We could govern app of apps feature of Argo CD, wherein we could integrate it with Crossplane to automatically create applications that are within the same environment. So we can visualize all the applications, including the containerized applications, as well as the AWS managed services in a single screen. So yeah, this is very important in case we have to serve this use case. Otherwise, obviously, we have other infrastructure as a core tool in the market. If we talk about the modular structure of Terraform, we were very much using that modules, and we were creating resources based on the modules that were either pre-existing in the Terraform or the modules that were created by us. So similarly, we also have a concept of creating the databases or any other things in the form of composition. We also have the composition resource, composite resource, and XRDs. XRDs are very similar to CRDs, but they are specifically made for the Crossplane. So they are composition resource definitions. So we can also integrate those high-level concepts with Crossplane to have a similar functionality to what we have with modules in Terraform. Again, this is still incubating. This is still yet to come out with more features in future. So yeah, we can wait, and we can also look out for more improvements in this tool. Yeah, with that, I'll conclude the demo and the session. Still, if anybody has any questions or doubts, you can reach out to me in Teams, or you can stay back after this session, and I'll resolve your queries. Thank you so much.
Let's extend this session to anybody having any a particular question about anything which they don't understand, or anything they would like to ask us right now. They can probably ask us right now.
In the newly created bucket, the data will be same as the previous one.
Can you come again?
when we delete a bucket from the AWS, then it will recreate a bucket. So the data will be remain same or it will be lost.
So, okay, so the data is not present. We just created a bucket. The objects within the buckets have not been defined, but obviously we have the another object which is defined specifically for the objects for the S3 bucket. So if we create it and if we delete it, the data will remain intact. That S3 bucket that got created was empty. That is why we did not had any data in it. So yeah, but if we create objects within the SE bucket, it will take care of adding those same objects.
Okay, thank you.
Anything else? We still have I think 5 minutes. If you have any other question regarding Kubernetes or for Crossplane, you can shoot your questions right away. Let's utilize the 45 minutes we have booked. As I earlier said as well, the advantages of Crossplane are many. So if you could have seen the managing of your applications or resources, or again, you can extend it to multi-cloud as well, right? So you can manage your resources and applications across multi-cloud. So basically, how you play with the particular provider-specific API. This is how you play around with tools like this. So again, it is declarative. So you can use a declarative API that enables you to define your infrastructure and application as a code. Obviously, infrastructure as a code tools such as Terraform or CFT, cloud formation is what I'm talking about right now. But resource combination, or composition, how much you are going to play around with your resources or infrastructure. Definitely with your integration with your Kubernetes, which enables you to, let us say, manage the type and the kind of infrastructure you're going to use. Again, the same Kubernetes API you're going to use there, right? So it is powerful again, as I said earlier as well. Um, you can basically destroy. I'll repeat this. Basically, destroy your resources when you want. This is how you save cost and resources which you do not want anymore. This is basically not for prod environment, basically, but mainly when you destroy uh, the pre-prod environment. So that is where it helps a lot, and you can destroy the linkage between your S3 buckets, your EC2 instances, and obviously your databases as well. Sometimes you might have a disaster recovery setup somewhere else, and now you have a new disaster recovery setup. So you want to destroy your that database or that S3 buckets. Again, as I said, you can play around with several layers. So layer zero is where you'll probably be playing layer one on the compute layer, where you will be playing layer two. Basically on the policy level, and then on the code as a policy is what the question was about during the session as well, right? So on the layer zero, and then on the compute layer, and then on the services layer, so layer two. So if you are able to manage these three on a single API, on a single tool called Crossplane, I think that's how the benefit of hybrid environments you can play around. Um, Crossplane is open source, so that is one of the best part about it. Obviously, you have several other tools as well, but multi-cloud control plane is what it provides you. So if you're going around and going to provision, deploy, basically do a CD uh, 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 continuously, that is how you'll probably be using it. And then if you have to play around multiple provider configurations, that is where you will utilize it as well, because you keep on changing the multi-provider configuration. So you can do it with your Terraform, but if you can do it with your Crossplane, I think that is one of the best part of it. Uh, so I think that's what I could have given you today. If you still have questions, you can ask us right away. Yes, Abhishek, go ahead.
What Kubernetes cannot done without Crossplane?
What Kubernetes cannot do
Without
without what?
Crossplane. Without
Without?
Crossplane.
Okay, so what is Crossplane? Crossplane is giving you an let us say control plane, right? Whereas Kubernetes is your orchestration platform, right? Right. You understand my point, right? So what cannot Kubernetes do? Kubernetes has to provision certain resources. For example, load balancer, which you will have to control via a controller, so that can be inside your Kubernetes. But for example, when you are using multi-cloud environment, Kubernetes was originally designed to have your application container and you put wherever you want, right? But when you are using Kubernetes, you have to understand on the layers. So layer 0 is your user, right? So where the federation will happen. Now the federation will tell you where you are moving, the ID, right? Now if you don't have support to move around various clouds, the federation cannot single-handedly help you. For that, Crossplane tells you this is the API you are going to hit, right? Federation single-handedly cannot help you, right? And obviously, uh, Kubernetes has their own API, right? You have your containerized application wherever you have put it. Now, Crossplane have it unified here at a single point. Now you know where you are hitting, where you are destroying, because it is declarative, right? Now you manage it with Kubernetes API or you manage it with Crossplane API. The use case is what matters, right? Right. So that is how the use case differs. Whether you want to use the Crossplane or not depends on the multi-provider configuration changes that you want to do, especially code policy as a code. That is how I'll probably look at things. Any other questions, ladies and gentlemen? Alrighty. I think we are on time, right? 5 o'clock. All right. So thanks a lot, Vidushi, for this wonderful session. I think this has been one of the more contemporary session which we were looking forward to. So thanks a lot, Vidushi.
Yeah, thank you everyone for joining.